Now let's talk little bit about combinations and the case when repetition is not allowed. Before, we have already discussed in much more detail that what are permutations, and we discussed both of the cases when repetition is not allowed and when it is allowed. Now it's time to talk about combinations. You already know that order does not matter in combination. So it means if I am dealing with numbers, for example, so 1 2 and 2 1 are same things when we are dealing with combinations. So a combination doesn't care if it is 1 2 or 2 1, it is same thing to a combination. And the formula to calculate the number of combinations is n factorial divided by r factorial, n minus r the difference, and factorial. And we name this whole quantity as NCR. You are familiar with the variables n are the total number of choices available to you, and r is the size of the combination or the group you want to make, the size of the combination. So once again, you can remember according to my method that you can also consider that n is for no, c is of course for combination, and r is for repetition. So no repetition, and if you are dealing with combinations, it's NCR, and your scientific calculator has a built-in function for NCR, so you can do it in few clicks. Let's solve an example to elaborate what is the difference between a combination and permutation. So it is an unusual question, but I hope you will feel the difference. We have three numbers, 4, 5 and 6. Okay. And now how many permutations and combinations of two digits can be created from these given numbers? Compare the results. Repetition is not allowed. So we are given three choices. Okay? This is the first choice, this is second choice, this is third choice, and it's very easy. The total number of choices available to us are 3. And they told us how many permutations and combinations of two digits. So it means size of the permutation or combination is same, it is 2. We already know to calculate the number of permutations or combinations, so let's use the formula. To calculate the permutations when repetition is not allowed, it's easy, NPR. And to calculate the number of combinations when repetition is not allowed, I have just told you it's NCR. So we have n is equal to 3, so it's 3p2, and for the combination it is 3c2, and my calculator tells me that 3p2 is 6 and 3c2 is 3. Okay, so I can make 6 permutations but only 3 combinations. And let's see the results and try to understand what is the difference. So here is the comparison. So total permutations are 6 and total combinations I can make from these 3 digits is 3. So here is the comparison. I have done it manually. So here I have 6 permutations and I have 3 possible combinations. So you see the difference. The first permutation is 4 5. Similarly, the first combination I have chosen is 4 5, right? Similarly, the second permutation of size 2 is 4 6. Similarly, on the left side, the combination I have, my second combination is also 4 6 from the 3 given digits 4 5 6. Okay, now the third permutation is 5 6, and third combination is 5 6 as well. Now here comes the difference. The fourth permutation is 5 4, but I don't have any combination as 5 4. You know why? Because a combination is insensitive to the order of the things. It only cares about the combination and not the order of the things inside the combination. So if I have a permutation 5, 4, 5 is on the left side and 4 is on the right side, a combination will say that no, 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 I already have this thing at first place. 4, 5. You may say, no, 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 this is different because 4 is on the left, 5 is on the right side. But the combination will say that, dear sir, I don't care about the position, what is left and what is right. As long as I have the two numbers 4 and 5 in my combination, in my two boxes, no matter wherever they are. I have 4 and 5, two digits in my combination. It's okay, it's enough. I don't care if it's on the left box or right box. It's the same thing to me. So a combination will not accept this thing. Same is the case with 6, 4 because 4, 6 is already there. So a combination will say, okay, I have 4 and 6, these two digits in my boxes, and I don't care wherever they are, in which boxes, right or left, I don't care. But as long as I have the two digits in my combination 4 and 6, it's enough. I cannot take this one as a new combination because it may be a permutation, because permutation cares about the position of the number in the box, whether 6 is on the left and 4 is on the right, or 4 is on the left and 6 is on the right side. And you can now imagine what is the case with 6, 5, because 5, 6 is already there, and a combination will say, it's okay, it's enough. I have 5 and 6 and I don't care in which boxes they are. As long as I have 5, digit 5 and digit 6 in my combination, it's enough. I don't care about the positions, whether they are in the left box or right box. It's same to me. I can't see the difference. You can imagine combination as a blind for position of the objects in the combination. So you see, so I have 6 permutations but only 3 combinations. So here is the difference. And now I hope you will be able to solve the questions. Your questions will be different, of course. They will not involve any numbers because our numbering system is position sensitive. So I hope you will never see an example like this which I have presented. I presented it just to show you that can you see why a combination is insensitive to the position of the objects inside the group. So here is the difference. But you will see the problems where you will not see problem like this when there are numbers involved, because our numbering system is basically position sensitive and combinations and don't care about that, and there is a big conflict between the two. So your problems will be different. We will solve an example like that. Okay, so let's talk about combinations when repetition is allowed. So some students might think it is not in their course of study, but I want to include this part because for some students it may be interesting to know, or it may be included in their coursework. So I will just talk very quickly, and those students who are not interested to know about the combinations when repetition is allowed, you can simply skip this part of the lecture. So the formula to calculate number of combinations when repetition is allowed. So here is the formula, and you are familiar with the variables. N are the total number of choices available, and R is the size of the combination. And now the repetition is allowed, and you know that a combination doesn't care about the position of the numbers. For example, if I have two numbers 1 and 2, and I want to know how many combinations I can make if repetition is allowed. So remember, I can make 1 and 2, then I can make 1, 1, and then I can make 2 and 2, because now repetition is allowed. I can't make any other combination. Don't fall in the trap that I can make a combination of 2, 1. No, that is because I am talking about combination, and combinations don't care about the position, because 1, 2 is already there, right? It doesn't care where is 1 and where is 2, but 1 2 is there, it's enough. It will not take this as a new combination because it is the same combination. It doesn't care about the position. Yes, because now repetition is allowed, so 1 1 is fine and 2 2 is fine. That's it. So I can make 3 combinations in this situation. Now let's take an example, a similar example, but we did when the repetition was not allowed, and now repetition is allowed. So we are given 3 numbers, 1 2 and 3 4 5 6. N is equal to 3 and R equals 2, because we want to know how many 2-digit numbers can I make. And remember, this time repetition is allowed. We can repeat these numbers. For example, I can repeat 4 2 times, or it depends on the size of the permutation or combination. So have a look at the formulas. If repetition is allowed, the number of permutations are equal to n power r. So 3, n is 3 and r is 2. So I can make 9 permutations if repetition is allowed. Similarly, if I use this formula, my calculator tells me I can make 6 combinations if repetition is allowed. Remember that. So here is the comparison. These are the results from my previous part of the calculation, and now because repetition is allowed, so just see, I have 6 permutations, and because the repetition is allowed, so I want you to see that there will be 3 more permutations. What are those? 4 and 4, 5 and 5, 6 and 6, right? So 6 7 8 9. I have 9 permutations because now repetition is allowed. So you see the difference. For the combinations, it's same. I already have 3 distinct combinations, and now on top of that I will add 3 more combinations because now the repetition is allowed. So 4 4 5 5 6 and 6. So I have 3 4 5 and 6 combinations, and my formulas were right. I can make 9 permutations and 6 combinations if repetition is allowed. These formulas are all right. You just need to remember these formulas. And if you want me to reiterate again, because the difference between combinations and permutations, that combinations don't care about the order of the items in a combination. For example, this 5 4 permutation is not accepted as a combination because 4 5 is already there, and a combination doesn't see the order. For example, that 4 is on the left and 5 is on the right, but I am giving it a arrangement where the 5 is on the left and 4 is on the right. A combination will not take it. Combination only cares that I have digit 4 and digit 5 in my boxes. That's it. It doesn't care in which box is 4 and which box is 5. As long as it has 2 digits, 4 and 5 in its 2 boxes, that's enough. So on top of that, because now repetition is allowed, so 3 more combinations are added, so total are 6. Similarly, 3 more permutations are added because now repetition is allowed, so total permutations are 9. And here are the formulas. Just in case you need it, you can remember them and you can solve the relevant problem.